For my unit plan, I have chosen to focus on the topic of forces, and my unit plan is named Forces Around Us. It is made for third grade, particularly 20 students. It will go through September 1st through October 16th, according to my curriculum plan that I created earlier in the semester. That is when I had it blocked off for. This will take me about 7 weeks. I will teach it for 3 days per week for about 30 to 40 minutes a day, which will be a total of 21 days of learning for students. And I particularly chose third grade because I am going to be student teaching starting here in December for a third grade class. And I thought that creating a unit plan for the grade that I'm going to be student teaching for would be ideal because I could potentially use this unit plan in my student teaching, because currently they're not really learning a whole lot about science besides for the STEM class that they went to once a week as a special, just due to COVID and just not having a lot of time for everything. Science is one of those subjects that had to be scaled back on a little bit, and so they haven't really been learning. So I feel like I could definitely use this unit plan in my student teaching opportunity to teach them a little bit about science. The goals of the unit, so students will build an understanding of the cause and effect relationships between objects when they interact and move, and students will also have a broad understanding of magnetivity. So I felt that this unit was important for students to learn and understand because in their everyday life, they're using force. So certain tasks such as writing with a pencil or playing soccer in gym class or riding their bike, they're using force. And so for students to be able to like relate what they do every day to something they're learning in science is really important for younger students to understand. And this is also important because students will be able to understand like why things work the way they do in terms of like things moving back and forth and things moving due to like putting force on it. And also this unit is going to help students understand like how magnets are related to forces in terms of picking things up or sticking to things. So they might have a fridge that's magnetic or a chalkboard that's magnetic. So just things like that definitely will help students in their life. Our phenomenon is how can larger magnets pick up larger positive magnets rather than smaller magnets. So I will be showing a video to the students of this crane that is holding a magnet and it is picking up all these little magnets, but it picks up one whole pile of magnets, but it doesn't pick up the little one. And so my before, during, and after picture shown here is kind of an example of what that video looks like. And the compelling question that goes along with my anchoring phenomenon is, how do objects affect the motion of other objects? And throughout the unit, I have these following supporting questions just to help guide students through each lesson, which are, what do forces do? What happens when forces are balanced or unbalanced? How can you predict patterns of motion? What can magnetic forces do? And what can electric forces do? So the following is a copy of my summary table of all the lessons that will be used throughout this unit. My unit consists of about 6 lessons, the final lesson particularly being an overview of the summative assessment that students will be creating. And so that's kind of like the last day we're going to wrap up stuff. And then the following week, students will be working all week on their summative assessment. So lesson 1 is, what do forces do? The purpose of this lesson is for students to observe moving objects and be able to describe how they are moving. Students also will be identifying the different forces that are acting on specific objects and how these forces change the specific object's motion. So this lesson is where I'm going to be introducing the anchoring phenomenon and explaining to students what it is that we're going to be investigating throughout this unit. So data and/or patterns that will be observed during this lesson are exert energy, push, pull. So this happened because each object acts upon another object and has a strength and direction. So relation to the anchoring phenomenon, there must be some kind of force that is being exerted in order for the metal pieces to be picked up by the metal magnet. The formative assessment for this lesson is a combination between lesson 1 and lesson 2. So students will be asked to write and draw a picture about a story in which they're playing catch, so throwing a baseball back and forth with a friend. I'm going to ask that they include the following events in their story. So their friend and them before the baseball is thrown, the direction of force when the baseball is thrown, whether the throw is a push or pull, and how does the friend stop the baseball, and what happens to the speed of the baseball. For lesson 2, it is called What Happens When Forces Are Balanced or Unbalanced. So the purpose of this lesson is for students to identify how different forces are acting upon specific objects and how both have strength and direction. So data and or patterns that will be observed during this lesson are exert energy, push, pull, objects exert energy on one another, cause and effect. Why did this happen? So when forces are balanced, there's no change in motion and the object remains at rest. When forces are unbalanced, forces are acting in different directions, causing a change in motion. So this relates to the anchoring phenomenon because there must be an imbalance in forces during the video because that means that the metal pieces are able to move upward onto the metal magnet. As I said before, the formative assessment for lesson 2 will be a combination between lesson 2 and lesson 1 about the story of them playing catch with a friend because it both has to do with forces. And as for lesson 3, it is how can you predict patterns of motion? So the purpose of this lesson is for students to observe and measure different patterns of motion. Students will look at different examples, such as someone swinging on a swing, a ball rolling back and forth in a bowl, and 2 people sitting on a seesaw. So data and or patterns that will be observed during this lesson are change of direction, change in motion, object motion can be observed and measured. Why did this happen? When past motions can be observed and measured, then the future motion can be predicted. So patterns can predict motion. So relation to the anchoring phenomenon, size and direction has something to do with why the magnet couldn't be picked up, but the one metal piece, but it could be picked up the pile of pieces. The formative assessment for this lesson, I will ask students to choose 2 different rides that they would see at an amusement park and provide evidence to describe how these 2 rides move in specific motions, either forwards and backwards, side to side. And I will ask that students draw a picture of the 2 rides that they chose and kind of write a brief explanation for how they can predict the motion that the ride will travel in. If students have never been to an amusement park, I will obviously have examples of some rides they can choose from if they are not sure of any. As for lesson 4, it is what can magnetic forces do? The purpose of this unit is for students to understand what magnets are, what magnets do, and how they're used in technology or everyday life to solve problems. Data and or patterns that will be observed are magnetic magnets. Why did this happen? Electric and magnetic forces don't require objects to be in contact with one another. So in relation to the anchoring phenomenon, the sizes of the forces and the distance between the objects relates to being able to pick up different things. For this formative assessment, it will be combined with lesson 5 because the assessment that I've created asks that students take what they have learned in terms of magnets and electric forces, which electric forces is lesson 5, to solve a problem using magnets. So for example, students could be asked to think of a problem that they have either at home or that we might have in the classroom or at school and design a tool that uses magnets that could potentially fix the problem that they have identified. Lesson 5. What can electric forces do? So the purpose of this lesson is for students to understand what static electricity is and how it works in relation to magnets. So data and or patterns that will be observed in this lesson are electricity, interaction, forces interact with one another and cause electric currents. So why did this happen? So cause and effect is what happens in terms of electricity. In relation to our anchoring phenomenon, the cause and effect being seen in this magnet cannot pick up the individual metal piece, but it can pick up the large pile of metal pieces. Forces are interacting with one another. So as I said before, the formative assessment for lesson 5 will be combined with lesson 4. And as for lesson 6, that will be the overview of the student's summative assessment, which is a fishing game. So this last lesson is where students are going to be introduced to their summative assessment. The purpose of this lesson is to help students demonstrate how they will be designing their own fishing game, which is similar to the anchoring phenomenon. Students will understand what is expected of them in terms of creating their fishing game and how it kind of relates to the anchoring phenomenon. So data and or patterns for this last lesson are kind of everything put together, all the lessons. So exert energy, push, pull, magnets. Why did this happen? So creating a fishing game that will pick up a fish requires there to be forces acting on objects, some sort of magnet, ideal size, and forces working together. In relation to the anchoring phenomenon is that by creating their own fishing game, students will be able to design a fishing pole that has enough magnetic force to pick up objects, so some toy fish that I'm going to have of different sizes. This design will help students compare and contrast their fishing pole to the magnet on the crane. Some anticipated challenges that I see throughout this unit are, I think that some students might have trouble with connecting all the aspects of the unit together. So the unit that I created talks about forces, magnets, electric forces, and motion. And I feel as though these subjects can be kind of complex. And so students might get a little confused and see how they all connect together in the one anchoring phenomenon. I also think that another possible challenge could be that students may think that all metals are attracted to magnets, which would confuse them when thinking about the anchoring phenomenon as a whole. Overall, I thought this unit plan was a really good way for me to understand the idea of ambitious science teaching. So I really enjoyed the micro teaching opportunities that we had in class, but I really liked being able to create a whole unit and create multiple lessons and a summative assessment that would tie everything all together. I believe that this unit planning project is a great resource to use for future student teaching opportunities, which is a possibility of what I might be doing, or when applying for student teaching jobs after graduation.